Alright, this video is for exam 4, page 4, section 1, and we'll be starting. So here is the question, number 3. Suppose that interval of 2 to 5 f of x dx equals -16. We also know that g of x is an even function, and interval of -2 to 0 g of x dx equals -6, and interval of 0 to 5 g of x dx equals 10. Find interval of 2 to 5 of 1/4 f of x minus 3 g of x dx. So first thing we need to do is distribute our interval to the rest of the equation. So following the rules, we're going to have 1/4 interval of 2 to 5 f of x minus 3 interval 2 to 5 of g of x. Now, whilst we do have our interval for f of x, so we'll have 1/4 times -16, we do not have our interval of 2 to 5 for g of x. But we do have all the information in order to find that. So first we know that g of x is an even function. So in that case, that means that g of x equals negative g, sorry, not negative g of x, equals g of negative x. And that means that when our x is the negative value is the same as x, our g are going to be the same. So what that means is that interval of -2 to 0 of g of x equals interval of 0 to 2 of g of x. We should also put dx there, since that technically isn't correct if it doesn't have dx. So in that case, they will both equal -6. So now we try to solve for interval of 2 to 5 using our interval of 0 to 5 g of x dx. And this works because interval of 0 to 2 g x dx plus interval of 2 5 g x dx equals interval of 0 to 5 gx dx. So as you can see, when we add these two intervals, we'll get interval of 0 to 5 gx dx. So now we need to isolate the interval of 2 to 5 gx dx. So interval of 2 to 5 g of x dx equals 5 to 0 gx dx minus integral of 0 to 2 gx dx. And so our 0 to 5 is going to be 10, and our interval of 0 to 2 is going to be -6. So when we add those together, interval of 5 to 2 gx dx equals 16. So now that we have our interval right here, we can now, what our interval equals to, we can now plug it in. So 3 times 16. So now we just solve for our equation. So this will give us -4. This will give us negative 48. And so our answer is negative 52. And that is all for this number 3. And next one is question 4. Given that big f of x equals interval of 1 to root x of ln of t squared minus t to the 5th over root t squared minus 8 dt, find dx d over dx f of x equals f prime of x by fundamental theorem of calculus. So this equation might seem daunting because we have quite a complicated equation and our interval has a variable in it. However, we don't need to do that much math in this case because with one of the fundamental theorem of calculus rules is that interval the derivative of interval of u times x over u of f of t dt equals f of ux times u prime of x. And what this effectively means is that we could take the upper bound interval and then plug it in for t in this case, and then multiply the derivative of root x and into next to the function. So in this case, our u is going to be equal to root x, and so our u prime is going to be equal to 1 over 2 root times root x. So, with that in mind, d over dx of f of x is going to be equal to ln of root x squared minus root x to the 5th over root x to the 2nd minus 8. All of this times 1 over 2 root x. And so this is our final answer for number 4. And that is the end of this video. I hope it's all good, and I will see you when I see you.